solution of previous year question. So question is given as what is the comparison between series and shunt compensation? That is the first part of the question. And in second part, write out one compensator each for series and shunt compensation. That means for answering the first question, you have to differentiate between series and shunt compensation, and in second part, you have to give the example of series and shunt compensation description. So, for answering the first question, I would like to draw the connection diagram as well as phasor diagram respectively. So, this is the circuit diagram of an uncompensated line. Say this is figure 1. Corresponding to this circuit, you have to draw the phasor diagram. So for drawing this phasor diagram, you have to take VR as reference phasor, and we are considering inductive load. Say I is lagging at an angle phi for this circuit. So draw across the resistance is IR and draw across the inductance is I into XL. So by adding this one, we are getting supply voltage space. So this is the phasor diagram of an uncompensated line. Now, in next case, we are connecting a capacitor in series with this one. So for this circuit, we have to draw the phasor diagram. Again, we are taking VR as reference phasor, and the total current, that is I, is lags at an angle phi. So draw across the resistance is IR. And the net reactance of this part is XL minus XC. Say XL is greater than XC. So net drop across this part is XL minus XC. So what will be the drop across this one? I into XL minus XC. So that is I into XL minus XC. And by adding this one, we are getting supply voltage Vx. So this is figure 2 and this is phasor. So what is the main observations we are getting? The line drop. Here the line drop is I into XL, but here the drop across the line is I into XL minus XC. So that line drop is decreased, corresponding to series compensation. Now, in next case, you have to add a capacitor across the load for shunt compensation. This is, and correspondingly you have to draw the result. again, VR is your reference phasor. Drop, that is the line current I. This is capacitor current and this is load current. So total current is I, that is divided into two parts, IC and IL. So say this is your load current. Again, capacitor current is 90 degree corresponding to here. So for getting the resultant current, what you have to do? IC and this is your resultant current I, and this is your angle phi. So drop across the resistance is I into R, and drop across the reactance is I into XL. So this is your supply voltage. So now this is the figure 3 and this is the figure 3. So what is the main observation we are getting from this phasor? The angle between I and V is decreased. That means power factor of the line will be increased. So these are the things which you have to mention whenever you are trying to compare the series and shunt compensation respectively. So you have to draw the 3 circuit diagram and 3 phasor diagram respectively, and from that you have to conclude